make it a semi-elastic collision. Okay, semi-elastic collision. What does that mean? Now, that means that two objects bounce off each other. However, their kinetic energy is still not conserved. Okay, it's not lost as bad as an inelastic collision, but it's still lost. So, in order to make this problem a semi-elastic, here's what I could give you. I could give you here. Let's use this problem, for example. I could give you one more unknown. Imagine here you have V1, V2, and theta, right? I could say now, imagine I could give you this V1, for example, but I need to give you a number that makes sense too. I can't just give you anything. What would make sense here? If the 2 kilogram hits the 5 kilogram and the 2 kilogram bounces off at an angle, what velocity would make sense here? Imagine going like this. This one goes like that. This one goes like that. So if this one is coming in at 2, what number makes sense here? Is it going to be above 3 or smaller than 3? Probably give it a kick. It's probably going to be smaller than 3, right? It's going to slow down a little bit. Let's say 2.6. Okay? So now, how did this make it a semi-elastic collision? Well, by giving you 2 of the unknowns, right? Notice how many unknowns I've given you. I've given you this unknown. I've said this is 35, and I've said this is 2.6. By providing 2 of the unknowns, I've now made it a semi-elastic because you no longer can set the kinetic energy to be conserved. You can only set the initial momentum in the x equal to the initial momentum in the y. Kinetic energy is no longer conserved. So Ke is no longer conserved when you know 2 unknowns and there are only 2 unknowns remaining. So the only thing that we can now do is set the initial momentum in the x direction equal to the final momentum in the x. And then we can set the initial momentum in the y equal to the final momentum in the y. So this makes it actually even a little bit simpler than before. Than in the total, because you only have 2 unknowns left. The final momentum in the x is what? 2 times 2.6 times cosine theta. And then the momentum of this is 5 times v2 times cosine 35, negative, right? And then the initial momentum in the x we already know is negative 4. Right? Then you have the momentum in the y, which is 2 times 2.6 times sine of theta. And then you have the momentum in the y of this one is negative 5 times v2 times sine of 35. And then the initial momentum in the y is 0. Okay? So now, this is a lot more doable. Well, all you do here is you solve for V2 in terms of theta. You get V2 is 5.2 sine theta over 5 sine 35, right? And then you substitute that V2 over here. So substitute it into this V2. 5.2 cos theta minus 5 cosine 35 times the V2, which is 5.2 sine theta over 5 sine 35 equals negative 4. So the 5 and the 5 cancel, and then this is tangent, so rewrite it as 5.2 cosine theta minus 5.2 sine theta divided by tangent 35 equals negative 4. Now solve for theta. Okay, is that much easier? You want me to give you this version of the problem or the previous ones? Okay, then be nice to me from now to the next test. Okay, get me coffee for lunch and good bagels and stuff in the morning. Then I give you the easier version here. 5.2 cosine x This one is a lot better. Not a lot, there aren't any parentheses or anything you have to worry about. 61.18 degrees. Okay? But now, here's what you got to do for this kind of problem. Usually the problem will also ask, find the percent loss of kinetic energy, because this is semi-elastic, right? So you got to find the initial kinetic energy, which is, we're using the same number, so we already know that it's 19 joules. Okay? And then you got to find the final kinetic energy, and then take their percent difference. Okay? So what is the, do we know, oh, we got to solve for V2, right? So we got to take the angle here, put it back into the equation for V2, solve for V2 here. So let's see here. 5.2 sine of 61.18 divided by 5 divided by sine of 35. So V2 came out to be 1.588 meters per second. Let's see, does that make sense here? It was going at 2 meters per second, and then it slowed down. Yeah, that makes sense. Yeah, they both slowed down. You see? So now the final kinetic energy is going to be 1.5 times 2 times its velocity squared, 2.6 squared, plus 1.5 times 5 times this velocity squared. So that's going to be .06 joules. And that proves that it's semi-elastic. It's not perfectly elastic. The kinetic energy is lost. Okay? So percent loss is 19 minus 13.06 over 19 times 100. It's going to be about close to 30% loss here, huh? $31.24. Okay, with that, we close that. We finalize that topic.